Imagine if the most powerful energy source in the universe was hiding inside what we call nothing. That sounds impossible. But according to quantum physics, empty space may not actually be empty at all. And that raises a question that changes everything. What if the vacuum around you is secretly overflowing with energy right now? Most of us were taught that a vacuum is simply empty space. No matter, no particles, nothing. But here's the strange part. When scientists zoom into the quantum world, reality starts behaving in ways that seem impossible. Deep beneath atoms and electrons, tiny particles constantly appear and disappear for brief moments before vanishing again. They're called quantum fluctuations, and every one of those fluctuations carries energy. This hidden energy is known as zero-point energy. At first, that might not sound revolutionary, until you hear the numbers. Some calculations suggest that even a tiny amount of vacuum energy could contain an almost unimaginable amount of power. In theory, a cup-sized volume could hold enough energy to dwarf anything humanity has ever produced. So why aren't we using it already? And this is where it gets weird. The existence of zero-point energy is tied to one of the strangest rules in physics, the Heisenberg Uncertainty Principle. According to this principle, nature refuses to reveal everything at once. The more precisely you know one property of a particle, the less precisely you know another. That uncertainty isn't a flaw. It's built into reality itself. And because of it, completely empty space may be impossible, which means the universe could be hiding an ocean of energy beneath the surface of nothingness. But if that energy is really there, why can't we reach it? And that's when things changed. Scientists quickly ran into a problem. Knowing that zero-point energy exists is one thing. Extracting it is something else entirely. The vacuum of space isn't truly empty, but it's incredibly cold, about 2.7 Kelvin above absolute zero. To pull energy from a source, you normally need something even colder to receive it. But here's the strange part. As far as modern technology is concerned, there is no colder destination available. The energy is there, yet it remains untouchable. Some theoretical ideas suggest creating a region where vacuum energy is reduced. If that happened, surrounding space would naturally try to fill the gap. In theory, that movement could be used to extract energy. Sounds promising, right? Not exactly. Current calculations suggest we'd spend more energy trying to harvest it than we'd actually gain. For now, it's a dead end. Or is it? What happens next changes everything. Imagine centuries have passed. Every engineering challenge has been solved. Humanity finally cracks the code and unlocks zero-point energy. Suddenly, energy becomes almost free. Electricity bills disappear. Public transportation costs nearly nothing. Developing nations gain access to technologies that once seemed impossible. Fossil fuels vanish. Even solar panels and wind farms become relics of the past. The entire global economy transforms overnight. But that's not even the craziest part. Because the biggest danger isn't running out of energy. It's having too much of it. And that's where the story takes an unexpected turn. Unlimited energy sounds like a dream. Until humanity starts acting like it has no limits. History shows a pattern. Whenever a resource becomes abundant, consumption explodes. And this is where it gets weird. Even if zero-point energy eliminated fossil fuels forever, new problems could emerge. Entire industries could scale beyond anything we've seen before. Massive energy use could reshape ecosystems, alter environments, and create consequences nobody predicted. The planet might survive climate change only to face an entirely different challenge. That's why governments would likely need strict regulations. Not because energy is scarce, but because it isn't. Yet the real twist may lie beyond Earth. With virtually unlimited power, space travel changes completely. Trips that once took months could take hours. Asteroid mining becomes routine. Permanent settlements spread across the solar system. Mars is transformed. Moons become cities. Humanity stops thinking like a planetary species and starts thinking like an interplanetary civilization. But here's the strange part. The greatest impact of zero-point energy may not be what it gives us. It may be what it forces us to become. A species no longer constrained by energy. No longer trapped on one world. No longer limited by distance. For the first time in history, our future would be defined not by what we can afford to do, but by what we choose to do. And if infinite energy truly exists beneath the fabric of empty space, then one question remains. Is the universe hiding humanity's greatest breakthrough, or the temptation that could change civilization forever?